So today I'm going to be talking about a lot of stuff. And thanks for coming to AMD Dev Day. Yeah, so OK. We're going to be talking about open source versus closed source. And how do we make open source models much better versus closed source models. For you guys who don't know us, we have, we're from Unsloth. And yeah, so we actually work with many organizations around the entire world. And we actually are the 10th most followed organization on Hugging Face. It might not sound that impressive, but we did defeat Microsoft a few days ago. Yes, thank you, thank you. Next stop is OpenAI, Stability, and Black Forest Labs. So we are trying to increase our following on Hugging Face. So definitely check our models out on Hugging Face. So for the work that we do, so for an introduction of what is Unsloth and what we do, so we actually fix a lot of bugs in open source models. For example, OpenAI's open source model, GPUs, we fixed a chat template problem. Meta's models, Llama, we fixed a few problems, Gemma. Even the large models, we had some issues. We essentially contribute these fixes to these large labs. And so we actually collaborate with everyone in the entire world on model bug fixes. So whatever model you have now that you download are most likely fixed by us. And so because of that, we actually have over 200 million total downloads on Hugging Face. We're the, I think, third or fourth largest distributor in terms of models downloaded in the entire world. So we try our best. So before these large labs release their models, we will now get early access to them, collaborate with them to make the model not be broken. We don't just fix model bugs. We also do other things. For example, we release something called asynchronous gradient checkpointing, which is used by many, many folks. We introduced this, I think, 1.5 years ago. We also introduced GPUs flex attention, which reduced memory usage to n from n squared for training, which is used by many folks as well. And we also contributed a gradient accumulation bug fix, which increased accuracy by 1 to 3% for all training runs. And so we do a lot of work that is not just model bug fixes, but we fix training runs and everything else around, in the AI stack. So has folks seen this plot before? This meta plot? Anyone know this or not? Or should I? So the meta plot, if you guys don't know this, you should search this on Google, meta. So METR. They have this very good plot showing you the capabilities of models over time. And this is a linear scale. And so on the y-axis is time of the task. And so for example, when ChatGPT got released, right, GPT 3.5, around 2022, December, November, that little over here, that's ChatGPT. And so in the early days of models, ChatGPT, if you guys used it, was actually pretty good. But it could only solve tasks which take 15 minutes, 10 minutes. Right? It can't do a complicated task. But then you see over time, GPT-4 was the first model that actually was quite powerful. And over time, these models, the capabilities of them keep getting better and better and better. If you see GPT-5, right, GPT-5, it can do a task that will take a human three hours to do, and it can do it. And Claude Opus is 12 hours. And so over time, the expectation is these models will keep scaling like this. But this is a linear trend. There is actually another, OK, now go to the previous, OK, this is actually a log trend. So previously, if you see this plot, right, this is a linear scale for time. But then we actually see this exponential progress. And the trick is you log the y-axis. If you log the y-axis, you see there's a linear trend. And so, yeah, so this is a linear trend, which is much more clearer. You can see now the difference between GPT 3.5. Right, GPT 3.5 could do something. Oh, OK. It's not 10 minutes, it's 36 seconds. So ChatGPT could only do a task that a human could do for 40 seconds. So it can only do general tasks. But now it can actually do many, these AI models can do stuff which takes humans 10 hours to do, and it can do it now. There is actually another plot on Meta. And so this plot is actually just 50% success rate. Right? So this means if you ask ChatGPT or Claude to do a task, it will only get it right 50% of the time. This one, if you want it to be 80% right of the time, then it looks like Gemini is a good model for that. And so if you want to do like a one-shot question, probably Gemini is better for that. If you want to do like a Claude, Claude is very good if you maybe try it twice, and then you might get the correct answer. Yeah, so like, I'm a very big fan of these plots because it shows you the progress of AI. But there is actually a but. This plot actually doesn't show the entire picture. I'm not sure if you guys can see. There is actually a weird line over here. Right after GPT-4 got released, GPT-4o, like there was this weird, it looked like the trend was going to fail for some time. Right, so like can you guys see that? Like there's like so it doesn't actually follow the linear trend. And the reason why this happened is because O1 preview got released, and it changed the slope of the entire plot. So previously, if we didn't have reasoning models, this trend will fail. And only because of reasoning models, the doubling time has actually changed. And so essentially what it shows is reasoning was the reason why these models keep getting better and better and better. And that's the only reason. If reasoning was not discovered, then AI progress will probably slow down. And only because of reasoning, this red line, you can see the acceleration to be even more prominent. The doubling time of these models' capabilities is now 4 months. So what this means is every single 4 months, before, like for example, 4 months ago, the models can only do something which is like 12 hours. 4 months later, it can now do a task which is 24 hours. Previously, it used to be 8 months. Now it's 4 months. And so it's actually quite remarkable that these AI models are getting even more better at a faster rate just because of reasoning. There is actually another benchmark which I really like. It's called the Weird ML Index. Previously, I showed that this is the reasoning. So reasoning is the red line, and the blue line is non-reasoning models. And you can see that there is like a trend. You can show that reasoning models are much more capable. But this benchmark shows that actually it's false. So reasoning models are actually not that much better. They are better, but they're not like a changing slope. Like some sort of like actually the slope has changed, right, in this regime. Reasoning models and non-reasoning models, according to the Weird ML benchmark, they're like similar. It's just a little bit more capability. And this benchmark is actually very good because it does like very weird machine learning problems, very hard scientific problems using maths and stuff like that. So definitely check this one out as well. This is a very good benchmark. Another benchmark which I really like for open source and closed source models is the long context benchmark. So I actually had to like extract this data from, there is a context arena. So if you search in Google context arena, they have some very good data. They updated the database actually yesterday, or was it 2 days ago? And these lines show you the accuracy over context length for all of the models. And so I call it as yellow is Anthropic's models. Yellow is Anthropic's models. Blue is the open source ones like DeepSeek, ZAI, Moonshot, Kimi, and stuff like that. And the green ones are Google's models. And the black lines are OpenAI's models. I'm not sure if the benchmark had some problems, but it seems like Opus 4.7, it kind of died in terms of context. So probably the benchmark had some issues. But Opus 4.6, over time, if you increase context length, the accuracy does decrease. So it's not like these models can do reasoning and work over long contexts. They do work very well, but you need to be careful of looking at this accuracy plot. For example, I don't know if you guys use Claude Qwen and stuff like that. There is an automatic compaction window. How many tokens you want for the compaction window. According to this plot, you should make the model as 128K, and then you start compacting. Otherwise, you will decrease accuracy. And so this plot is actually very useful to show you the capabilities of these models. I actually color-coded it even nicely, just showing open source models. So the gray lines are closed source models, and you can see open source models somewhat lag, in terms of long context performance. There is some lag in terms of performance, but they're doing better, right? So over time, these closed source models and open source models will converge over time. And so, like, for example, some folks have said, these models have, 256K context length, 1 million context length. You can see the accuracy is not good. It's only 20% accuracy. So if you don't Want to use long context? Probably don't need to. Just use 16K, 32K, 64K. You already get 80% accuracy. Yeah. Okay. Another plot which I really like is, remember previously I said over here, right, the reasoning models are the reason why AI models are getting better. I actually have, so artificial analysis has this very nice plot as well, showing you the performance of reasoning models, open source models and closed source models. So the black line is closed source models, and the blue line is open source models. And you can see, I actually plotted two other lines, which is when O1 preview got released and when DeepSeek released their paper. You can see that at this certain time over here, this was, I think this is GPT-4o, I think. GPT-4o, and this is Meta Llama 405 billion. You can see that at around September 2024, open source and closed source was exactly the same in terms of capabilities. But OpenAI released O1, and it changed the entire landscape because it shifted the entire industry to do reasoning models. And you can see after that time, the closed source labs had a very large lead. But over time, you can see the open source models finally figured out how to do reasoning, how to make these models better and better and better. Actually, there is another plot which I really like, where you take the difference between the two lines. And this is the plot that you get, right? The difference, this is how many months behind open source is. And you can see previously, before O1 got released, it was around 6 months delay, right? Closed source labs were 6 months ahead of open source. But then after reasoning came along, I would say this is like the open source drought. Around 2020, so last year, open source was behind by 16 months, right? 1.5 years behind. And so open source the models were not very good. But look what happened now, right? Open source models have catched up again, and they are only 6 months behind now. And in fact, sometimes they're even 4 months behind. The graph is a bit skewed because, when you take the model releases, they were like, it will make the minusing a bit more complicated. But you can see that open source models have returned back to having a 4 to 6 month, delay. And I feel like this is actually very important. The main question now is, will the closed source labs have some new innovation again to again go back to the 16-month, 16 months ahead of open source models? Our view is, I don't think so. I think the reasoning paradigm is like the final, like you can hear like OpenAI trying to go back to not doing reasoning models. They're trying to do like, more, fine-tuning, more focus on like trying to reduce the reasoning length. So it looks like maybe reasoning has run its course, and we need something more. And so I think that this plot is very good to show that open source has caught up dramatically. Another very good plot that I really like about closed source labs, so this is Claude Code's, I'm not sure if you guys see Margin Lab, but definitely follow this. What Margin Lab does is they show you the performance of Claude Code every day. Like Claude Code always does like, improvements in their harness, updates, but it can actually affect accuracy. And so this plot shows you over time, what is the accuracy of Claude Code every single day. They run, I think, 50 SWE bench problems every single day and do an average. And you can see that there are some weird dips in terms of Claude Code's accuracy, right? In fact, generally speaking, Claude Code's accuracy is around 55-ish%. But actually, at some times, it's not very good. And these values, they're not fake. They're actually real. A very good example is actually AMD. Stella from AMD posted about Claude being worse. And there was actually a GitHub issue for this. And the fundamental point is Anthropic actually released a few days, I think it was last week, about their post-mortem. And they actually had 3 issues in the Claude Code harness. And I pasted this before, but essentially the main point is Claude Code did get worse. And the reason why it got worse is the thinking got deleted one time before, and there was a bad system prompt. And Anthropic, because they fixed it, now the accuracy has shot up. And this is also because of Opus 4.7. But because of these bugs in the tooling, the model becomes dumb, right? So it's not actually the model that becomes dumb, it's the tool that becomes, the tool was the problem. And so the main point, yeah, they have this post-mortem. They also had another issue. I'm not sure if you guys know, Claude had last year they had an issue, which was, I think they did some I think I have some, okay, I didn't have a slide for that. But last year, they also had some issues. People were saying how they did quantization. They had some issues with accuracy and stuff like that. They do have like a blog post on this as well, like a post-mortem. But the main point I was trying to take away is the harness is the most important now. It's not the model, right? The model is not important anymore. It's the tool, the harness. So okay, another word for the tool is the harness. So Claude Code is the harness. Open Code is the harness. Codex is the harness. And these tools or harnesses are now the problem of changing the accuracy of these models, right? So like, for example, if your harness was not good, you will decrease accuracy by 30%. So if your harness is good, then you can increase accuracy. And so in open source land, these harnesses can be very problematic. One of the biggest problems for open source models is tool calls will keep failing. And Claude, if you ever read Claude Code's transcript, Claude Code actually fails tool calls as well, all the time. But they just hide it, so you wouldn't actually see it. But open source models, the problem is open source models, you can actually see everything. And it looks like open source models are not good. Okay, it looks like open source models are not good, but they're actually very good. And the trick is you need to enable something called tool call healing, where after a tool call is created, you want to heal the wrong tool calls. And we show that, if you fix the tool calls, you can actually increase accuracy dramatically. So previously, the tool calls which fail, it actually failed 10 out of the 10 times for Qwen 3.5, 4 billion. So tool calls will fail. After healing them, 0 times it fails. So it successfully did it. You also want to actually you also want to give the tools to the open source models, like web search. Previously, if you don't fix the tool calls, it will do web search 0 times, right? Even if you tell it you can do web search, it doesn't do it. After you fix it, it will now do web search for 40% of the time, which is much better. And yeah, like essentially there are many ways you can do, and actually it's funny, when you fix the tool calls, you actually reduce the number of tool calls. So your inference time is actually faster. And so there's like many weird tricks you can do to make open source models work very well. This actually kind of partially was interesting as well. If you use Claude Code with open source models, please be careful of setting the correct parameters. So Claude Code, it does something special where it injects a system message which changes over time. So every single time whenever you reload up your coding environment using Claude Code, using open source models, it will actually invalidate the entire prompt. And so your inference will become 90% slower with open source models. And you must use export Claude Code attribution header to be 0, and then this will just delete that system prompt thing for open source models. And yeah, like there are many things which you can do to make inference faster for open source models. And this is another trick that you can employ. And yeah, like I think I already talked about this previously. Like open source models always have bugs. And so we try our best to fix issues with these models. Like for example, Kimi K2 had an incorrect system prompt. We had to inform them about this. Wrong end of sentence token, so like the model will generate forever. There are many issues that these large labs have, and the goal is we want the community to help trying to like fix these open source models to make them even better. Yeah, like a very good example is Gemma. So for example, Gemma, so we had like a Gemma 1 bug fix that we did where the PyTorch conversion was not correct because the Google folks like to use JAX, which is a very good framework. But once you convert it to the PyTorch land, the conversion systems are different. And so we found that you need to do some tricks to make the PyTorch land work. And also we found that there are like huge activations for Gemma 3 training. And so you need to be careful of that as well. So we fixed all of these as part of Unsloth. And yeah, like if you want to experience open source in general, we fixed tool calls. The models are all fixed. Everything works very well. They're all part of Unsloth Studio. So we actually release all of our research, all of our work that we do as part of Unsloth Studio. And you can also learn how to like train using AMD GPUs. So actually there's actually a workshop, there's actually a workshop afterwards where I tell you how to use AMD GPUs, of how to do reinforcement learning, training, using the Strix Halo laptops as well. So we actually have support for this as well. And yeah, like another thing that closed source and open source labs have in difference is closed source labs have large-scale reinforcement learning runs. And so the goal of these closed source labs is they want to reach AGI, And how to reach that is they will do 10 million different environments. So for example, playing Sudoku, doing weather simulation, trading stocks, doing maths. Imagine 10 million environments. And then once you combine all of this, their goal is to do massive scale reinforcement learning to make AGI become possible. That's kind of their goal. But that's the trick. The trick is open source has the same tools as the closed source labs. Okay, maybe compute is a bit, compute is a different problem. But closed source labs can still, we as open source, because DeepSeek released a GRPO paper, we now have the same access to the tools as closed source labs. So we actually have lots of notebooks of how to make faster kernels, how to play the 2048 game, how to solve reward hacking, and many other things on our docs. So definitely check that out. Oh yes, and also we have a workshop afterwards. If you want to learn how to do reinforcement learning with Ryzen GPUs, Ryzen laptops, the Strix-Halo laptops, there's a workshop afterwards as well. And yeah, have a check on our, we upload all the bug fixes to the models, to our Hugging Face. Definitely check that out. And I think, yes, thank you so much for coming to AMD Dev Day. Thanks for listening. Also, if there's questions, I can wait, other questions? Or question time? Is there question time? Okay, yes, okay, questions. Yes. So that is a good question. So compute is a problem. And so the open source world, what they do is instead of focusing on trying to get more compute, how do we make smarter algorithms to solve the same problem? So for example, as part of Unsloth, we made training 2 times faster, use 90% less memory. So we can solve the compute problem by being smarter with the algorithms. So that's one way that the open source world can do. But also, for example, AMD actually has a dev cloud. So AMD provides free GPUs as part of AMD dev cloud. So you can actually access AMD GPUs via that. Yeah. Yes.
What does it take for an open source model from US to reach to the front end?
That is a good question. So the graph that I showed previously showed that open source is still behind by 4 to 6 months. But my estimation is it will, I don't know if I have to store, okay, let me just check the plot. Where's the plot? Here, right? So recently, it seems like open source can sometimes be 4 months behind. And my take is, if the large labs don't have some new invention, like no more reasoning, like no more special source, then this trend will go to 0 months. You will see open source models commoditize AI, probably. But that's maybe. Okay, this is a maybe. But I think my guess is, Anthropic, the large labs, OpenAI, they are working on something special to increase capability even further. And so this trend might reverse again. But I think my take is we are currently stuck in the regime of 4 to 6 months. There is another trick. For open source models, if you see this plot, where's this one, the meta plot, right? 80% success rate, right? This is the 50% success rate. Just run the open source models 10 times. And then remember, if the success rate is 50% for one run, 1 minus 50% is 50% failure. But then if you, 50% to the power of 4 or 10, the success rate becomes like 90%. So all we need to do is run the open source models 10 times more, and then you will get the same accuracy. Well, it's a trick. It's true. It works. Yeah. Yes, any other questions? Yes. Do you mean why do we debug open source models but not closed source models? Or so our work mainly is in the open source space. We could have access to closed source models and help that. So for example, Anthropic themselves have issues with Claude Code. They fix their models themselves and stuff like that. But they do leverage some of our work that we have. For example, we do, for example, the Gemma bug fixes, the Llama bug fixes, the large labs do see that, and we collaborate with them on that. But I feel like we are open source first. Our view is we want to democratize AI. And so our view is we don't want to, maybe it's more like our view is open source should be priority first. And so our goal is to fix open source models first. Closed source, okay, maybe I'll rephrase. Closed source models always have bugs. Just, you can't see them. They will hide it under the rug. No one can see it. But the problem with open source is everyone can see everything. So if Gemma has a problem, for example, Google fixed the chat template yesterday again. So if open source has a problem, it looks like there's so many problems, but actually open source doesn't have more problems. It's just the closed source labs hide it under the rug because you can't see a change log. You can't see okay, they increase accuracy. For example, the this plot. Where's the meta plot? Right, this one, the margin lab plot, right? For example, these large dips show that Anthropic did something wrong with the model. It's not fake. But they're not going to blast it out and say, oh, our model's wrong and broken. Please, everyone get a refund or something like that. They're not going to say it. But the problem is open source, everyone can see the code. Everyone can see the changelog. Everyone can see everything. And that's why open source, it looks like it's more buggy. But it's not. Yeah. Yes.
What's the importance of ensuring that we can actually see the changelog versus being unable to do so? And from what I understand, if you can see the changelog, you're getting if there's a problem, but you fixed it. But if you keep it closed source, like you point out here, you
Yes.
never fix the problem. Yes, people are still committed to the board.
So Anthropic, so OpenAI, Anthropic, so they're actually not, they're trying to be more transparent. For example, Anthropic released the, wait, where is it? Is it before or after? I don't remember anymore. Oh, no, it's after, right? So Anthropic did release their post-mortem, right? Oh, it's here, right? They actually did respond. They said that they had some issues, like the thinking got deleted and a bad system prompt, right? They actually say okay, we stuffed up. We fixed it. But it might take some community pushing to do that. I think OpenAI is probably a bit better in terms of this because Codex, for example, the OpenAI engineers use Codex that you guys also use. But I think Anthropic, the only problem is they don't use the Claude code that they distribute. They have like an internal development. So maybe one way to solve that is they should use what we use as well. And then they can see the problems. But I feel like these closed source labs, they're trying to communicate better. But I do agree, open source is just more different. Yeah. Yes.
In addition, how do you create some kind of like, I guess, good communication where then you can let people know that, hey, we have a problem, we're working to fix it versus there's a problem, therefore everything is burning on a fire?
Do you mean like, how do we do communication better or?
Essentially, because it's one thing to admit there's a problem, but that problem can be achieved in various different ways. And if the effort to fix it is important, then how do you communicate that properly?
Yes.
People thinking that everything's on fire because there's a problem in the first place.
Yes. So interestingly, we actually had the same problem. So every single time we communicate a fix to the community, the community thought that we were the ones who broke the model because we found the bug and we fixed it. And so we are also learning how to communicate this properly. So most large labs, what they do for the open source models is they fix it and then they tell people, oh, we fixed the model, like not the community, but the distributors, like us or Olama or LM Studio or whatever. They'll tell them, we fixed the model, please update the model. And so what they like to do is they like to they like to divert the communication to the distributors, like us. And so we still need to learn, like I'm not sure, like for example, Qwen, there were many issues, Gemma had some issues, Llama, every single open source model has issues. And we're the most transparent. We tell everyone like, okay, there's a bug fix here, there's a bug fix here, there's a bug fix here, there's a bug fix here. Please re-download, please re-download. People sometimes do get annoyed, but I feel like, I don't know, like I'm not sure how to solve this problem. But there are like many bugs in open source models, and we will try to communicate to people better. Yeah. Yes. Okay. Yes.
Yes, you mentioned that running the same open source model 10 times to solve the problem because of increased
Yes.
accuracy.
Correct.
You also mentioned that the harness is going to be the critical.
The most important.
What is it that we can do to modify the harness to improve accuracy of the models?
Very good question. So this is where open source can shine. Because now it's not about the model, it's about the harness. Everyone can work on the harness. For example, I'll give you a very good example. Every single time for example, how do you edit the system prompt that is part of Claude code? You can delete some tools, for example. Like some of the tools are not very necessary. For example, if you never want to use Jupyter Notebook editing, delete the tool. You're wasting 2K tokens or something in your system prompt. Example. You can do like skills. You can make some special skills. So every single time, whenever you like launch some sort of workflow, save it to like a file and tell it, okay, you can now execute this Python function. Another very good example is every single time, whenever you go to auto compaction mode, when the model starts compacting your conversation, because like pretend you like go to 600K, how do you make that process better? Do you like you keep like a transcript of your conversation on the side, and then you tell like a model summarize the user and the assistant prompt to like a transcript, and then during compaction you can then use the transcript to make the long context compaction better, something like that. But because now you were focused on the harness, you can have many ideas and experiment with them. Another one, right? Instead of doing one Claude code instance, can you launch 10 codexes to do the same problem, and then gather everything at the very end, and then give it back to Claude code? I don't know, something like that. But you can do many, many things. Yeah, that helps or something. Yeah. Okay. Is it time? Oh, okay. One more question then. Yes.
Do you have some like models, either in-house or like a wrapper of the open source models? How can we use your tools to find out like what the bugs are there?
So do you mean? Oh, do you mean like you want to know what are the bugs in the models? Like how do you identify the bugs in the models? Okay, we do not have a tool which does that. The main problem is every single large lab, they have different chat templates, they have different tooling. So we actually have to manually inspect if the models have bugs. We have automated like 90% of all the bug fixes, but there's still this 10% which always causes pain. And so unfortunately, it looks like, generally speaking, we will have to fix the bugs. If the community complains to us, we will fix it. And so I'm not sure if that answers your question, but yeah. But we do have some blog posts of how to actually, so I have some YouTube videos, I think. I did it with PyTorch and some other folks of how to actually identify bugs in the models. So we have some videos on that, if that might be helpful. Yeah, okay. Well, thank you so much for coming. Yeah, appreciate it.